I was a girl in the village doing all right. Then I became a princess overnight. She's
Right. So much to
to
learn
learn
and
and see.
see.
Up in the castle with my new family. It's a
It's
school.
I don't know.
Just
All right.
I don't know the rest.
All right.
All
Lesson.
right,
Lesson.
this is lesson
Lesson
7.
4.7. 4.7.
In my way.
And after that wonderful introduction, I know you guys are all fired up now to learn about classifications of solutions, which, by the way, is what we're talking about today in lesson 7. And we're going to take what we've been doing with solving equations and kind of take a step back and say, wait a minute, before we go through solving this, can I tell what type of solution it's going to be? So again, take your excitement right here and let's roll with it. So classification of solutions. We're going to start just by solving equations, and then we'll talk about what the answers look like. So this is a good review. Remember what we've done before. I tend to always start by rewriting our subtraction problems as addition problems. So instead of saying 7x minus 3, I'm going to say 7x plus a negative 3 equals then 5x plus 5. All right, and then if we want to, again, talk about both sides of our equal sign, we can put those lines in. And each side is simplified. We still get simplify each side, then gather our x terms up on one side. I'm going to choose to get rid of my 5x on the right by subtracting it. Whatever I do to one side, I have to do to the other. 7x's take away 5x's, I'm left with 2x's plus a negative 3 equals, that adds up to 0, so that cancels out, so that equals 5. So now we're at a two-step equation. I'm solving for x, so I have to get rid of the negative 3. I'm going to do the opposite. I'm going to add 3 to both sides. And then I'm left with 2x. That gives me 0 equals 8. This is 2 times x, so I'm going to do the inverse or the opposite, and I'm going to divide both sides by 2. 2 divided by 2 is 1x. 8 divided by 2 is 4. So we get a solution of 4. Okay? And then I want to go through all these problems, and we're going to come back and talk about them. Because again, we're talking about the types of solutions we can get here. Okay. Move my screen down a little bit. There we go. Okay. So look at this one is very similar. Okay. These all actually are pretty similar. So let's start by, again, rewriting it as an addition problem. So we have 7x plus a negative 3. Subtracting is the same thing as adding the opposite, or I'll say keep, change, change. And that's going to equal 7x plus 5. All right, each side is simplified, so let's gather our x terms up on one side. I'm going to choose to get rid of the 7x here on the right. So I'm going to combine it with a negative 7x, or again, you can think of it as subtracting 7x. If I have 7x's and I take away 7x's, that's 0, cancels out. I bring down my negative 3, bring down my equal sign. Again, if I have 7 and I take away 7x's, if I have 7x's and take away 7x's, that cancels out, and I'm left with 5. Now, this is something we've seen before. We get a solution of negative 3 equals 5. We know those aren't the same thing. Negative 3 does not equal negative 5. So in this case, we would say that there's no solution. And we're going to try spelling it right. I don't know what I was trying to spell there. Notice I said try to spell it right. Okay. So again, just following our steps here. Next one looks really similar again. So let's follow what we've been doing. I'm going to rewrite this as 7x plus a negative 3 equals negative 3 plus 7x. Put my lines in here. Okay, each side is simplified. So now I'm gather my x terms up. I'm going to get rid of the x term on the right here. So I'm going to combine it, a positive 7x with a negative 7x. And whatever I do to one side, I do to the other. That gives me 0. I'm left with negative 3 equals, bring down my negative 3. That gives me 0. Now notice how this is a little different than this one. This was not true up here. Negative 3 doesn't equal negative 5. Does negative 3 equal negative 3? Yes. Okay. So this is going to have a different way. We know this is no solutions. What we're going to say here is actually infinitely many solutions. And the reason we're going to say infinitely many solutions is because notice that it's always going to be true. And actually, if you look real close here, especially if I rewrite it here, this is 7x plus negative 3. This is negative 3 plus 7x. It's adding. Commutative property says we can change that order and switch it around. So these basically are the same thing. We solve it, negative 3 is always going to equal negative 3. So it doesn't matter what we put in for x, we're always going to have the left side equal to the right side. These are our 3 type of solutions. The one we did up here, up top, okay, where we got 4 for an answer, what we say here is this is a unique. If you're unique, you're an individual, okay? There's only one of you. We're all unique. So if we have a unique solution, there's only one solution. And I'm going to really just struggle with spelling the word solution today, apparently. Okay. Now, we also have no solution. So what are 2 of our 3 choices are unique solution, no solution, and of course, infinitely many solutions. And I'm rewriting these because we're going to put some characteristics underneath. Infinitely many solutions. Infinitely many. Any number to infinity we can put underneath that. Okay, so now we're going to put our characteristics in, so we don't necessarily have to solve it to know if they're going to be infinitely many solutions, no solution, or a unique one solution. What I want us to focus on right here is our coefficients. Remember, that word coefficient, it's the number attached to the x. So once you simplify each side, it's a number multiplying the x. You will have a unique solution if they are different coefficients. That's kind of why it's important to remember that word coefficients. Okay, so if you have a problem and they're simplified on each side and you have x's on both sides and the 2 x terms are different coefficients, in this case it's a 7 and a 5, unique solution, keep going to solve it. Okay, you're going to get a number that it's equal to. It might not be an integer, but you'll get a number that it's equal to. No solutions. Okay, there's going to be 2 characteristics of no solutions. In this case, once it's simplified here, or even in the minus up here, if they have the same coefficient, so notice in this case they are both 7s. Sorry, that's not right. So same coefficients. Pause. Look down here. Again, not the first term, the number that's attached to the x. Same coefficients. Okay, so if they have the same coefficients, the numbers attached to our variable, in this case x, that's either going to be no solution or infinitely many. The way we know which one it is to check out the constants. Notice in the no solution, we have different constants. Constants are the numbers without a variable. It's constant. It's not going to change. No matter what number we put in for the variable, still going to be negative 3, still going to be 5. Okay? But down here, this is why it's important to change it to addition too, so you can see that this is a negative 3. They're going to have the same constants. So we have 3 types of solution. We have a unique solution. That means different coefficients, keep solving, you're going to get an answer. We have no solution. No solution says, hey, wait a minute, we have the same coefficients, so the same x terms, but our constants are different. Never going to work, okay, because our coefficients are going to make those x terms cancel out. Never going to have a solution, so we get no solution. And then the third option is infinitely many. When we have the same coefficients and the same constants, they might just be written in a different order because of the commutative property. If they're the same though, both of them, we're going to have infinitely many solutions.